of you who just joined, I record my class meetings and put them on YouTube. And that may be part of the reason why it seems like some of the students aren't here today. I make it a little bit too easy maybe to think, I'll just watch the video later. I'll just watch it later. All right, so announcements. Homework 8 is due on Monday. That needs to be uploaded to Blackboard before class on Monday. Remember that when you're doing problems on Excel, you need to make it really clear what your final answer is. So take the time to annotate that file and maybe highlight in yellow your final answer and articulate what was the decision criteria that you used to make your judgment. Really put some effort into making it a document that's full of communication and easy for the grader to understand what you were trying to do. Reminder about the project, it's due on Friday. So Friday the 19th of November, not a week from today, Friday. But in class on Wednesday, we looked at a couple of links for inflation and cost of living adjustments. Let's just take one step back. Maybe some of you are still working on the income part of the project. I wanted to show you a useful data source that may be a valuable point of reference. I'm not saying it should be the only thing you look at, but it is a thing you can look at. Usajobs Gov, which is where all jobs, it's where all of the government positions are posted regardless of the agency. So the Forest Service, the civilian positions within the armed services, Department of Commerce, everybody. And so, for instance, if we go to USA Jobs and type in computer science, I know that there's some students in computer science, and we'll just pick computer science. And then over here on the right, we filter for jobs that are intended for recent graduates. Okay, so we'll look at some of these. Here's Department of the Air Force, National Security Agency, and the NSA. That sounds potentially kind of interesting. So you click on that, and it'll tell you the pay scale range, GS7 to GS15. Now let's do another Google search here. Federal pay scales GS 2021. All right, now whether you start off at GS7 versus GS15 depends on your qualifications and experience. And so if you scroll down, it'll talk a little bit about, first of all, what's the nature of the job, like the languages they hope you know, the background knowledge, and then here's some information about salary. And they'll say, for example, entry level is with a bachelor's degree plus relevant experience. I think I was looking at this earlier, and there are some where you don't have to have any relevant experience, like truly entry level, like no previous work would be maybe when you're starting off at GS7. So if you were reading through the description and it said GS7 based on bachelor's degree but no previous experience, you could go to find, this may be a non-PDF. All right, this is a good one. Let's click on West Virginia. And so it's showing what is a GS7 Step 1, which means your first year of employment at a GS7. So that would be $49,157 per year. But notice this is for the Washington area, which has a locality adjustment of 30%. So if you're living in not the Pittsburgh area of West Virginia, but if you're living in rest of West Virginia, I guess if you were working for the NSA, you'd be in DC, right? So in this hypothetical where you're working at the NSA, maybe it'd be the DC part. But if you found one of these jobs for the federal government and it was based in West Virginia, then you'd want to look at what's the pay scale for the GS7 in West Virginia. So during the first year, it's $43,683. So that's kind of low. The private sector is going to be paying more. But the point is this USA Jobs is a valuable data point where you're trying to get like an idea of what's the range of salaries you might earn once you graduate. So you could do the same thing that I just did for computer science. You could put in mechanical engineering. And do a new search, I'll turn off the computer science and leave the recent graduate filter on. So you'll notice that there are going to be dozens and dozens of jobs available where one of the keywords was mechanical engineer. And so you can read through the position description. Now some of these maybe are somebody in mechanical engineering that just has a 2-year associate's degree. Maybe a GS5 would be like less qualified than you'll be when you start your career. So spend a few moments reading through the position announcement, because they're hiring people in a wide range of experience and the salary is going to be different. So that's usajobs.gov for the part of the project that has to do with the income. Okay, so any project-related questions related to income or inflation, of cost of living adjustments, anything at all? One last thing to point out. So GS7, step 1, this $43,683, that would be your first year in that job. Step 2 would be after 1 year of experience. And so this $45,139, that's not a cost of living adjustment. That is kind of like an experience increment. And so next year, these pay scales are going to be even higher for not only step 1, but also for step 2. So you could use this federal pay data to keep track of not only what is the pay going to be as you progress with more experience within a certain job, but then if you got a promotion, you'd go from GS7 maybe to GS9. And then you'd start over at GS9 step 1 in your first year. Your second year in GS9 would be step 2. But then in addition to the experience increment, remember there's also the cost of living adjustment, where every year your salary is going to be going higher. And to get a sense for that, remember you'd multiply this year's salary by 1.05 if 5% was your assumption for inflation, and then that would tell you what the salary is going to be next year. All right, so you really need to read over that project description and understand the totality of the assignment, and let me know if you've got questions. Okay, today we're going to continue with incremental analysis. Remember, on Wednesday, the increment was the difference between two options. And today, that's the same meaning of the word increment. It's the difference between a cheaper alternative and a more expensive alternative. But this time, what we're going to be doing is looking at things in terms of their annual cost. And so we did it kind of on a present worth basis last time. Today we're going to do it on an annual worth basis. Now think about some kinds of equipment. It makes sense to consider in terms of how much they cost to own on an annual basis. Like maybe equipment that gets replaced fairly often. Laptops, for instance. Maybe you'll just keep a laptop for 2 years or 3 years at a time. And so maybe instead of having that lump sum purchase of the laptop every 3 years, maybe it makes more sense for some companies to think of it as a periodic expense where they just set aside every year $500 to have a certain portion of their company's laptops replaced. And so computer expenses for them are an annual expense. When that's the case, it's good to do the incremental analysis on the annual worth basis because the equipment itself is considered on a recurring interval. So what we're going to do is find the rate of return on the increment. And remember, the increment is how much extra it costs to buy the more expensive alternative compared to a cheaper alternative. So we went through a list of interest rate definitions, different ways that the letter I is being used. And delta I star is the rate of return, the internal rate of return on the increment. And so we're going to find for the difference between two alternatives what interest rate makes it so that the two annual worths are equal. And when you solve for that, for what interest rate makes the two annual worths equal, then that's the rate of return on the amount that's extra between them. So I think that just like last time, this will probably all make more sense when we look at in the context of a specific example. And so the in-class example that we're going to go through today looks at two different pieces of earth-moving equipment. One of them, it looks like this is a Bobcat, option A. Let's just say, for instance, that it has an initial cost of $8,000, and then every year the maintenance and operation and fuel expenses of that equipment is $3,500. And we anticipate it's going to last for 10 years, but then it has no salvage value. It's just completely worthless at the end of the 10 years. And in contrast to that, option B has a higher upfront initial cost, but its annual expense is much lower. It only lasts for 5 years, but it does have some positive salvage value. So what we want to know is option B is more expensive. So what's the rate of return, what's the percentage return that we get if we choose option B? And we want to find it out on an annual basis because obviously these have different amounts of time, 10 years versus 5 years. And the way that we can compare alternatives that have a different study period is either the repeatability, the least common multiples approach, or there's contract services where you're using some rental equipment for the remaining years that need to be studied. With the shorter lifespan you'd extend. And then there's early termination where you take the longer option and you make it shorter by selling the equipment early. And then there's a fourth alternative, and that is just compare the two items on an annual worth basis. And when you do that, you're assuming repeatability applies, but you don't have to manually invoke the repeatability. Okay, so let's open up the template file that I sent you. The handout, today's in-class exercise handout, has a procedure that's kind of step-by-step outlined for you. We want to know this extra $5,000 that it costs to get option B, what's the rate of return on that extra $5,000? So we're going to begin with a spreadsheet file, and then I give you these step-by-step instructions on what to do, and it involves using GoalSeek. So let me download the template so that we make sure we all see it together, what it looks like. Thanks for stopping by, guys.
Thank you.
All right. Have a good day.
You too.
Okay, so you open up the template file, and the instructions on the handout here tell you what to do. First of all, enter an initial guess. And so I'm going to pause for a second and give you a few moments to read and absorb the instructions that are described in the handout. And I'll be circulating around in case you want to verify that you're putting the correct things into the right cells. Feel free to chat with one another. Of course, we don't need to be quiet during these in-class exercises. It's definitely a good time to collaborate. Watch as I put in the info and maybe double check your solution to make sure it was the same approach. I'm going to talk through some of the mistakes you need to be on the lookout for. So we're just going to put in a guess, 1% as a starting point. Option A lasts for 10 years, whereas option B only goes for 5. The initial cost is $8,000, and since it's a cost, I put in a minus sign, comparing that to $13,000 for option B. Annual equivalent of the initial cost. Several of you are remembering the idea of capital recovery. Capital recovery is when you put in both the initial cost and the salvage cost in the same function. So that's a thing, but that's not what's asked for here. This isn't asking the capital recovery. This is just asking the annual equivalent of the initial cost. Okay, so we're going to do PMT function to find the annual equivalent. First of all, it's prompting us to reference the rate, so let me anchor that. The NPER, number of periods, so I'm just going to click here, but I'm not going to anchor it, because then if I don't anchor it, I can move the formula over to column B, and it'll look in the correct spot. The only thing I do want to anchor is the interest rate reference. Okay, so I don't anchor the NPER, comma, now it's asking what's the present value. This is a present value. There isn't a future value. If I was doing capital recovery, I'd put the salvage value into the field for FV, but I'm only annualizing the initial purchase price. So I exclude that future resale value. Okay, I forgot the negative sign. See, it took an initial cost that was an outflow and turned it into an inflow. So I got to remember to put in the minus sign in the PV because I want it to stay as a minus. All we did was annualize it. And so now I can Control C and Control V and paste that equation. And it does the same thing. I'll just click over here to make sure it's looking in all the right spots. It got the interest rate. Here for NPER, it's looking at 5. For the present value, it's looking at the initial cost for this thing. Okay, so option A had an initial cost, annual, $3,500. B has an annual of $1,600. The salvage value was 0 versus 2,000. And that's a positive because that's money you get when you sell the equipment. So this is a lump sum future value 5 years in the future. I want to annualize it here for this component Z. So I'm going to do equals PMT to take either a present or a future and turn it into an A. So PMT function is kind of like find A given either P or F, depending on what you put into the function. So this PMT function is find an annual amount. Is there a question in the back? No? Oh, I thought you were raising your hand. All right, that's fine. You can touch your masks. I won't call on you. I always like to joke around and like if someone's just scratching their head, say, yes, do you have a question? Put them on the spot. It's teacher humor, you know? All right, so rate. I'll click on here, anchor the reference to the rate, NPER, number of years. Now I'm skipping over the present value because this salvage value isn't in the present, it's in the future. So minus of the future value. So I'm just trying to spread out the F into an A. Find A given F. So 2,000 lump sum at year 5 is the same as getting 5 equal annual payments of $392.08 when we have 1% interest. So now I can Control C and Control V over here. Well, 0. I guess I didn't even need a formula for that. 0 salvage value is going to be 0 annual equivalent. Sum of the annual costs. So it's the initial cost, operating costs, and salvage value. And I can drag that over here to the side and find the difference between the two, one minus the other, or I could do this one minus that one. Of course, if we see these pound signs, it just means that we need to make it a little bit wider. Okay, so I am looking for my objective, according to the instructions, use goal seek to change delta I star until the difference is 0. So I star means the unknown internal rate of return, and delta means on the increment. So the difference between these two, so the $5,000 extra that option B costs, I want to know what's the rate of return for that. And so I'm going to do here the goal seek. I could either manually adjust it, 0.02, getting closer, 0.03, this is getting tedious, 0.04. So let's manually do it, or use data, what if analysis, goal seek, and our objective is set the difference to 0 by changing the interest rate. 12.65% is what we're looking for. So then our conclusion is the rate of return on the extra $5,000 that option B costs is 12.65%. Which option should we choose, A or B? Well, I don't think this problem even ever said what our MAR is.
It goes on the bottom.
Does it on the bottom? What does it say? Okay. Yes, at the bottom. Thank you. It says you must choose option A or B. If your company's MAR is 9%, which is best? So if it's 9% is the MAR, should we choose B or A? B. You're right. Why should we choose B?
Because 12.65% is higher than 9.
That's right. 12.65% is more than 9. So that means choose the more expensive alternative if the rate of return on the increment is greater than the MAR. That's the decision criteria. And let me explain it this way. If your company's MAR was 9% because that was the borrowing cost, the question is, would it be profitable to borrow money at 9% in order to do something that returns 12.65%? Yes, that would be profitable. If you can take a loan at 9% and do something with the money that returns 12.65%, then you can pay the loan and keep the difference. And so you should spend every additional dollar you can that yields a return more than the MAR. So let's further this answer a little bit more. For a MAR of 9%, you should choose option B, since 12.65%, the rate of return on the increment, is greater than the MAR of 9%. So now we have not only the answer, but also an explanation that would help you to remember later on what was the decision criteria, like what was the frame of reference for the analysis and the decision. All right, let's take a quick look at the homework since we've got a moment. Boy, hard to believe we've already done 7 assignments. Time just flies. Homework 8 is due on Monday. Let's open that up quickly. External rate of return. That'll be good practice because that's really important. Incremental internal rate of return. That's what we did on Wednesday. Incremental annual worth analysis. That's what we did today. And then a bond question, just because those are everybody's favorite. All right. Oh, and another bond question, because I'm a super nice guy. All right. So we're both going to have really fun weekends. I'll be at Green and White Day tomorrow, and then we have our own ABET accreditation visit starts on Sunday. You'll be doing homework, and I'll be doing work as well. So just to finalize, remember that the assignment is due before 11 on Monday. If you have any questions on your work as you're working on it, feel free to reach out. I took a call on Teams last night about 9 o'clock as I was walking on the treadmill at Planet Fitness, and I was glad to do it. It was far more interesting than any of the trash that was on the screens above me. So, you know, if you have a question and I'm available, I'll pick up. So reach out and let me know. That's it. Have a great weekend. I'll see you next time.